We got 10 subnets, 10.1, 10.2, 10.3, 4, 5, 6. And now R1 wants to advertise all this. R1 you want to run OSPF on all interface so that all the link will be running OSPF and the advertisement will be sent to R2. If that is your expectation, instead of going inside this 6 interface, you can simply go under router, OSPF process ID, network 10.0.0.0, 0.255, area 0. When you do that, here you see you got wildcard mask. It matches the match bits is only in the first octet. These bits do not have to match. So all the interfaces that has got 10 in the first octet will be now running OSPF. So this configuration is more simple because you don't need to go to all the interface. Just one line of configuration enables OSPF on all the interfaces.
That's right. This is what I was referring to. I don't think you mentioned network in the yesterday's lab.
Yesterday's lab I did not do because
Yes,
I never used this method. This is old method.
so this one is called what method, sir?
I call it as classical method.
Classic. Okay.
But I always go under the interface and whatever the interface that I want to run, OSPF I say IP, OSPF 1 area 0. Boom.
Right. Okay.
So this is much better for me. If I'm comfortable, anyone you can follow.
Okay.
This is available only in the old method. Sorry, this was the only option in the old operating systems.
Right.
Nowadays, no one uses that old operating system. Everywhere we see a new sub. The new supports both this as well as this.
Okay. Thank you, sir.
So this is one question to ask. Second question is there any way that a default route can be injected? Yes. On router 2, if you go, for example, I want router 2 to inject default route to rest of the routers. There are various ways in OSPF. One of the way is router OSPF1 default information. Originate always. That's all. When you put this command, it will inject default route to R1 and R3. Let's go to R1 and see. Show IP route OSPF. You see you got a default route. What is the other question you ask?
The
Cost.
cost.
Cost can
So
be.
with the default route, is this also on area 20 and area 0?
No, further you need to go to that ABR. Border only should
Okay.
inject you. No, this is not simple like EAGL. This is a big autonomous system. Big autonomous system, many areas. So for each area, you have ABR, which is responsible to provide that.
So what I was asking is like if you want to ping outside OSPF, like if you want to ping to the internet.
Yeah. See, whether you are pinging internet or other area, where you are going to pass through the border, isn't it?
Yes, sir.
Can R1 go to other area without going to R2?
No, sir.
Can R1 go to internet which is connected to R4 without going through R2?
No, sir.
Uh,
It has to go through area border.
yeah, when area border router provides a default route, it is applicable for all unknown destinations. That unknown destination may be other area, that unknown destination may be different autonomous system like internet.
So you have to write in. You have to write the command and all the area border routers.
Correct. If you want on all areas, then you go and write it on all the ABRs.
Okay.
Right.
The last one is the cost,
The
sir.
cost.
Like,
Cost.
how does it work?
The cost of OSPF can be manually configured, but most of the people they don't do that. Most of the engineers don't do that. They allow OSPF to do auto cost calculation automatically. How OSPF is going to calculate is what we are going to see now. Let's say we got three different speed links. This one is 10 meg, this one is 100 meg, this one is 1000 meg. We got internet or some destination. There's a default formula called cost is equal to 100, which is used as a reference, divided by the bandwidth on the link. The bandwidth is 10 meg on the top, the far top link. So the answer is 10. So the cost is here. Auto calculator cost is 10. Here the cost will be 1, isn't it? 1. What about this one? Cost is equal to 1000 divided by 1000, 100 divided by 1000. What do you think the answer will be?
Is it 1?
Correct. Even though it's 1 by 10, a fraction number will come. But this is not a mathematical class. This is OSPF. OSPF will seal it to 1. So in this also cost is 1. It is all because of the numerator value, the reference value. When they designed OSPF on those days, they kept 100 as the reference value, thinking 100 cannot be reached. 100 meg will be the reference because 100 meg cannot be reached. That's what they were thinking, but nowadays we have 1 million meg bandwidth. So we need to change this reference. For that, the command is, say for example, you see here on R1, I'm going to change. Before I am changing, I'm going to show you on R2, show IP route OSPF. you can see the cost as 1 because for each link it is 1. From R2 to R1, one link is there. Switch is not considered in layer 3. It's one link, one broadcast domain. So cost is 1 because the speed is 100 meg. The fast Ethernets are 100 meg. And loopback is another one. That's why you see cost is 2. But I'm going to change the reference bandwidth to 1000. I'm going to change the reference bandwidth to 1000.
So question, how come it is 2 days on the routes?
I told you the loopback interface cost is 1.
Oh, okay.
Plus the physical interface 100 meg cost is 1. 1
Okay, sir.
plus 1 is 2. Now I'm going to change the reference bandwidth. When I change to 1000 instead of 100, it will be like 1000 divided by the actual bandwidth is 100. So the cost will become 10. So you will not see here 2 after I finish that configuration. But again, I'm telling you, if you are doing on one router, you have to do this on every router to get the proper result. Anyhow, I'm not going to do on every router. I'm going to do only on R1 and R2 and R3. And testing network is 1.1.1.1. Right, this is the command. Router OSPF1 auto cost reference bandwidth 1000. Sorry, 1000. 1000. So let me do it on other router. R2. Router OSPF1. Okay. I don't want to do it on R3. This is enough because my testing network is 1.1.1.1. You see now? The cost has become 11 because this link is 10 now. This link is 10. 1000 by 100. Plus the loopback interface is 1. That's why 11. So you can you can change the auto cost reference bandwidth by using that command, which I just shown you. This one. Right? Shall we go to ACL now?
Yes, sir.
All right. Access control list is nothing but set of permit and deny statement. Permit and deny statement. Access control list is set of permit and deny statement. That's why it is list. They're not saying access control. They're saying access control list. So we may have more than one permit and one deny statement in one list. When I say I got access list, it doesn't mean that there's only one policy. Allow this. No. There may be more than one also. So Access control list, a set of permit and deny statement. I can say permit X, permit Y, deny Z, permit C, like this, and apply it to the router. When a packet comes to the router, if it is X, it matches the first line itself. So this is one access list. And this will have an ID, let's say 10. Access list 10 is applied on this router. Access list 10 has got how many entries? 4 entries. Permit X, permit Y, permit C, deny Z. So when the packet that approaches R1 matches the first line X, it permits and it will not look into the second and third, fourth line. It won't go. If match happens on the very first line, it won't go down. In case if the incoming packet is not X, then it will check the second line. Is it matching with the second line? Y. Is it Y? No. Is it Z? Yes. Then the action taken will be deny the packet coming from Z and permit nothing from D. Will it read the fourth line? No, because there is a match found. Let's suppose that there is a packet coming which is K. The packet is coming to router 1 and it is K. Is K matching on any of this line? No. What will happen to that packet?
Shiveen,
My question was, I'm receiving a packet whose destination is K. What will happen to that packet? Do you have any answer? We don't have K in any of this line.
it will allow, sir.
Okay. That's one answer. What about Mahesh?
I don't know, sir.
There is only two options. Either permit or deny. What is your answer?
Maybe I'll just say deny. Maybe there could be a default one which would deny because it doesn't matches all the above, so it might deny at the end.
That is correct. Srinam, actually what Mahesh is correct. You know, when access list is written, there will be always one last line. Even if you write 100 line, there will be 101th line, which is invisible, saying deny anything. Deny any. Deny all.
Sir, but we, after creating the access list, last line we give any.
That is permit any. But I have not said here, no, in this example.
Okay.
This example I have not said permit any. So if your last line is permit any, then the match would have happened here. When K comes, K is one of any, isn't it? It would have permitted, as Sriram says. It won't get denied. But problem is, if you don't have this last line, the you written, if you don't have this line written by you, in that case, if we don't have this line written by us, in that case, what is the default? Deny any. So we call it as implicit denial. Implicit denial is at the bottom. To overcome this implicit denial, we put permit any. That has become our usual habit. Permit any, permit any. But the reason why we put that, this is the reason. Because by default,
Implicit deny means so only the access list will match the criteria in that access list, right? The rest all will be implicit denied.
correct.
Okay.
Whatever matches according to what is being defined when match happens will be given, will be taken, action will be taken. For example, if matches with Z, package should be denied. But what if packet is K? There is no K mentioned, but it is matching here any, which is implicit. I did not write this statement. Implicitly, it is there to deny everything that doesn't match. That's how it get denied. But if I would have said permit any as my last line, this implicit deny would have been the line after what I configure. Always. That's why it is implicit deny. You did not explicitly configure it. If you configure this permit any, then this deny any will be after permit any. So when K comes, because it is matching with any, will get permitted. Implicit deny at the bottom. So we have seen a few rules now. What is that? Access list is set of access control entries, not just one entry, entries. In our case, we got 1, 2, 3, 4, including this permit any 5. 5 lines we wrote, the sixth line comes automatically, deny. Now if I write 10 line, 11th line will be automatic, deny any. Whether we like it or not, it will be there. That's how the
Sir,
firewall
one more doubt.
policy should work. Yes.
So if you're not giving anything implicit deny or permit any or deny any, but still it'll block, right? It'll not it'll deny, right?
See, implicit deny we did not give.
Okay.
It will be there by default.
So still it will be denying, right?
Yeah, it will be denying.
Okay. That's why we are giving it with the permit
Permit
any
any.
also.
Yes.
Okay.
See, it is like access list is like one security. Security means they are very strict always. Otherwise, they cannot be a security. They have to blindly follow the orders. Then only he can be a security. So you have decided as a director of the company, you have decided that you will allow only the employees doing the work hours. And you have given the list of employee names to the security guy. Permit this fellow, permit this fellow, permit this guy, permit this guy, permit this guy, with the ID. So when when the employee comes in with the ID, you match with the with the list given by the company owner, the director. The security matches with it, compares with it. When there is a match, he allows him. When someone comes and says, I'm a close relative of your director, allow me. Um, he says, no, I don't have anything related to you in my mail, which means I'm supposed to deny you. That's my job as a security guy. I have to deny you because nothing about the director's relative is shown here, said in this. So he will not be allowing this relative inside. That is what implicit deny. Is there anywhere the director told, if my relative comes, deny? No. He did not say that. But as a security person, he has to do that. Because he is given with a list whom to permit. What does that mean? Others should not be permitted. Only then it is a good security. Any firewall features should do this. ACL is one of the firewall feature. See, today the definition of firewall has gone very big level. But initially in 2000, before 2014, firewall was having a small definition. Protect your network with the knowledge that you got to configure your firewall like ASA firewall. If you don't have ASA firewall or anything like that, you configure ACL on the router, edge router at least, to protect your network. Today, the concept called next generation firewall has taken to very big level now. You no need to do many things in firewall. You no need to do anything. Everything will be taken care. You just buy the box, connect it to the network, connect it to the vendor's data center. For example, if you are buying Cisco ASA firewall with firepower FTD, it will download all the policies from Cisco itself. And when the intruder tries to come, the firewall will know this is a dangerous packet. But you did not configure that. The firewall knows it is dangerous packet because early in somewhere in the corner in Uganda, that attack happened and the ASA was listening to the attack. There, the engineer has raised a red flag saying this is an attack traffic. So Cisco's data center have learned through Uganda's experience from one of the customer that this type of packet is an attack packet. So it will push this configuration to all the devices in the world through the internet. So next time when that similar attack tries to happen in India, the firewalls will be denying those packets. See, globally it is connected now. That is what next generation firewall. No writing ACL, no writing any policy. You cannot do that, right? Attack is worldwide now. For you to know about all the attack, even if you are an attacker, you will not know all type of attacks that are available on the earth. That's why it's centralized now. If attack happens to me here in India, everyone will know. And next time that attack will never happen anywhere in the world because all the devices are connected to the vendor's database. From there, the patches will be sent. So when same attack tries to happen in Australia, already your firewall knows that this is an attack and it won't allow there. So learned experience. There's a big team of people working. to provide the service for which you are going to pay per year or for every 3 years or every 2 years, something like that. That's what next generation firewall. Nothing your engineer need to know. Access control list is the kind of standalone firewall. You have a router which is now going to protect your network based on the policy that you write. Access control list is the way that you write the policy, the firewall policy. Whom to permit, whom to deny is a policy. Based on that, it is going to behave and protect you. Again, as I said, it's a set of permit and deny statement. The entries are read from top to bottom. When a match is found, it won't read the entries furthermore. It won't. And when there is no match, there is an implicit deny at the bottom, which is going to deny. So if you do not want get denied if there is no match, then you need to say permit any as the last statement, so that your packet will be permitted when there is a no match. Find what is next. There are two different access lists. One access list focuses only on the source of the packet. A packet is coming, it will check only the source. When the source matches, action is taken, either permit or deny. Only the source is matched. We call such access list as standard access list. Standard access list is identified the number between 1 to 99. That's standard access list. And then the extended access list is identified with the number 100 to 199. What is extended access list? The access list that will take action based on protocol, source, destination, and service. By comparing all these three, at least, this is an optional one. You have four different parameters to match when a packet approaches. If all these four matches, take action, permit or deny, or at least three. The service is an optional one. So there must be three things in the access list if it is extended. You have to mention what protocol of the packet, from where it is coming, where it is going. If you want to match these three and take an action, then you need extended access list. If you want to match only the source and take action, then you need standard access list. Standard access list only the source, extended access list protocol, source, and destination. What is the service here mean? You see, I want to deny TCP packet coming from 10.0.0.1 going to 20.0.0.1. If I say this, what all will be denied, you know? All TCP service, like LNAC, FTP, HTTP, HTTPS, everything related to TCP won't work. My idea is not to deny every service of TCP. I just want to deny only telnet service of TCP. Then I have to precisely say which TCP. TCP port number equal to 23. If TCP destination port number is 23, then deny. So let us say this is the only entry we wrote. If anyone does SSH, will it allow? No. Why? There is implicit deny at the bottom. So what we should have said is, we should have said permit TCP, any network, any, we have to say any, right? Only then rest of the TCP services will be permitted. Now my question to you is, if I will ping, the protocol is going to be ICMP, will that be pinged, will that be allowed or not? Kindly listen. The first line is TCP telnet deny. Second line I wrote TCP all other you permit. And I have applied this on the interface. It's a very strict security guy. A ping is happening. A ping packet is coming. Will it be permitted or denied? You tell me, please.
So will it be denied?
Very correct. The reason is we have said this TCP service deny and other TCP service permit. We said other TCP service only. We did not say rest all you can permit. We have a very particular saying other TCP. So instead of TCP, if you put IP, any IP service, it can be UDP, it can be TCP, it can be any permitted. So ICMP also comes under IP, will be permitted. When ping packet comes, it will permit. Because I have used TCP and denied, it doesn't mean that you also need to use TCP to say any. You can say IP if your idea is to permit all the rest of the services and packets except telnet. Except telnet, if you want to allow all other services, put IP. Don't put TCP there. If you put TCP permit any, then only TCP related services will be permitted like SSH, FTP, HTTP. But when someone pings or when someone does TFTP, when someone does DHCP, all those UDP services will not work. So using IP is what will allow other traffics, any kind of traffic to come in. Fine. I was telling you the access list is of two types, standard and extended. Standard access list matches only the source. Extended access list matches protocol, source, destination. Optionally service. If you miss any one of these three while configuring, if you miss any one of these three, command will not be accepted. Extended access list means you should have all these three. This is optional. In the standard access list, if you try to give source and destination, not allowed. If you try to add protocol, not allowed. Only source you should provide. Operating system will not allow any other except source. That's what standard access. In extended access list, you have to provide destination. What if I don't know the destination? Put any. You know the source very well, you know the protocol very well, but you do not know the destination. Put any. Right. So, yeah. Anyone has good question?
Excuse me,
Yes.
sir. Sir, in the below example, you've shown us the TCP1. Does that come under the standard access list
Extended.
or
You
the
see,
extended?
when you have protocol,
Ubiquitous.
source, and destination, then it is extended access list.
Yes, sir. Okay.
If only source, like deny 10.0.0.1, this is only source, then it is standard access list. So, by putting this number while you configure, you are telling the router that I am going to match only with source. By putting this number, you are telling router that you are trying to put protocol, source, and destination. Right. So after putting 150 as a access list number, if you stop saying only the source, it won't accept the command. It will say incomplete command. Because you have put 150, you are supposed to provide three info. Protocol, followed by source, followed by destination. Mandatory. So if the number is between 1 to 99, router knows that you're supposed to give only source, but if you try to give source and destination, it will say no, incomplete command or misconfiguration. It won't accept, first of all. It will show an error. It won't accept. It will say error in command or incomplete command, or it won't accept. It will definitely throw an error. Let me try to show you. Got this. You see, so if you will try to say something more than source like this, it won't accept. It won't accept. But if you remove this and say 77 is standard access list, you're supposed to match only this. If you remove that and say it accepts, no error thrown. Likewise, when I say access list 177, permit ICMP host 10.0.0.1, what I have given so far, I have given protocol, I have given source. What should be given again? Destination, but I am not willing to give destination. See what happens. Again it says incomplete command. Why? If it's an extended access list, three things must be there. The protocol, the source, and the destination. And if you want the destination, you give. Otherwise, at least you say any. Now it accepts because you got all these three parameters.
Sir, what was the reason that you wrote the wildcard bit before?
I repeat. Repeat the question.
What was the reason you wrote the wildcard bit before, after the host address?
You're asking this and this.
Yeah,
Okay,
that
listen.
one, 0.0.0. Why did you write
This is the
that?
equivalent of writing host keyword.
Ah, I see. Okay.
For a host, this is the IP address, right? For a computer.
Right.
So I'm
Yes.
saying by putting 0, this is the only IP address, which means host IP address. It's not a network IP address. Network will have more than one IP address.
So if you are giving host, then no need to give
If
wildcard,
you're
right?
giving host, then you no need to give wildcard mask.
Okay. Otherwise, we need to give the wildcard mask. All zeros means it will exactly
That one
match
address,
the
which is
criteria.
again a host.
Yeah.
Host means one single computer in a network.
Yeah. So if you are putting all zeros, it is exactly matching all the
All
octets,
4
right?
octets.
Yeah.
So now when I type access list 177 permit TCP any, it permits all TCP related service coming from any source going to any destination. If I say access list 177 permit TCP, deny TCP any to any equals 23, what am I denying? I am denying only those TCP services which is telnet. Right. Now you see the problem in configuration. Before this line, I said permit any. After that, I am saying no, deny telnet. Will this work? Answer. Will the TCP 23 be denied or not if the packet comes? If the telnet packet comes, will it get denied or not? It will not get denied. Why? You're writing this deny statement after permitting everything. The lines are read from top to bottom. The first line is this, second line is this, the packet matches in the second line, it will permit. The telnet packet matches here. Because you have not said what service in TCP should be permitted, what to be denied. Because you did not say what service, it will say all TCP I have to permit. It will permit. And then the next line you say, no, deny 23, it's of no use. Because the access lists are read from top to bottom, write the most accurate thing on the top.
So I think you were breaking off. I was not able to hear for about a minute,
I'm sorry for that.
and then it got connected
I'm
again.
sorry for that, huh?
I think even Sri Ram joined again.
Okay. Let me repeat what I was telling you. In this line, I permit ICMP, I allowed, isn't it? That's the first line.
No, I joined again as I have to drop my son to school. So I just going to his bus stop.
Now this is our
So
first line. Second line says permit all TCP. Anywhere to anywhere, permit. After that, you are doing third line saying deny if TCP packet is equal to 23 port number. This will not work. This deny statement will not be effective. Why? Because the entries are read from top to bottom. First, it will check with this. If there is no match, it will check with this. Even though it is a telnet traffic, it will be permitted because you did not say in this statement anything related to service. You said all TCP you have to permit. Telnet is one of the TCP service. It will be permitted. It won't read this line. Even though a telnet packet comes, it will not get denied. You need to write this line before this line. Show access list 177. You see, this line is going to permit all TCP packets. After this, if you say deny telnet TCP, will it be effective? No, it won't be. It won't be effective. I did not say enter here. Actually, I came out because there is no use of writing that third line. There is no use of writing this third line. I said permit. I wanted to say deny. Now the old line will be still there. You see, these two are useless because you said permit all TCP. Do you get the point what I'm trying to repeat again? Did you get the point?
Yes, sir.
So if you would have said this line as the second line and then this line as the fourth line, it would have been better. Telnet packet, deny. All the rest, it will permit. But don't do this one. This is useless line. Because access lists are read from top to bottom, but when the match is found, it won't read further. Put the most accurate statements on the top. Example, deny TCP any equal to telnet should be on the top. After that only you should say permit TCP any. You got this?
Yes, sir.
Right. So what we have seen is what is access list and what are the types of access list, and then the rules of access list. One more thing I want to add today is this access list is not only identified with numbers like 100 to 199 extended access list, 1 to 99 standard access list, not only by number, it can also be identified with a name. We call it as named ACL in ACL. So access list can be identified using number as well as name. With this I stop.